Hey grade 7s, welcome to your Friday math lesson. So in our last lesson, we were talking about being given different polygons and how to split up the triangles to figure out how many triangles can fit inside that polygon in an effort to figure out what the sum of all the internal angles would be. So for example, we have this shape right here, our octagon. If I were to split it up into different triangles, I would go 1, 2, 3, 4, 5, and 6. So there's 6 triangles. Our next one is 1, 2, 3, 4, and 5. So this one gave us 5 triangles. The reason why these numbers are significant, and here's where a little bit of algebra comes to play, but it's also a very simple pattern rule. As I was talking to you guys last time in our last lesson, there is a pattern rule for the number of triangles, how it increases by 180 each time. There's this simple formula that you can use to figure out the internal sum of a polygon. And you can do this without even being given the shape of a polygon. You can just be told how many sides it has. So if I told you a 15-sided shape, what would be the internal angles? That'd be really difficult to do unless you were drawing it out. However, there is a method. The rule with triangles is that there are 2 less triangles than there are sides. So to figure out, so we have a formula, is the number of sides of the shape, so the number of sides of the shape. So if I have a 15-sided shape, it would be 15 sides. Minus 2 equals the number of triangles. So for example, our octagon has 8 sides, we got 6 triangles. This shape here has 7 sides, I got 5 triangles. So that is our rule of thumb, is the number of sides minus 2 equals the number of triangles. However, we're not quite done yet. We have to figure out what number that amount of angles is. So let's try it with our 15-sided shape. So instead of drawing a 15-sided shape, I can just use our formula. So I have 15 sides minus 2 is equal to the number of triangles. So 15 minus 2 is equal to 13. So if I have a 15-sided shape, if I split it up into individual triangles, I would get 15 triangles. Or 13 triangles, sorry. 13 triangles. To figure out what the sum of that angle is, each triangle has a sum of 180. So each triangle is always adding up to 180, as we've discussed before, and we were trying to figure out the angles of the triangles. So 180. What I do is I take 13 as the number of triangles I would get, and I multiply it by 180 to get the total number of angles. So 13 times 180 gives me 2,340. So that means if I had a 15-sided shape, obviously that's not 15 sides, but if I had a 15-sided shape, if I add up all the internal angles, so all these little corners, I add them all up, it would equal 2,340 degrees. So let's try that out with a couple more shapes. We are going to try this out with some shapes let's start with the shapes that we've seen before in our last homework. So we've seen a 12-sided shape. So 12-sided shape. I have to plug in my formula of the number of sides, which is 12, minus 2 is equal to the number of triangles. I'm just going to do a short form of this because it's a little hard to write with this thing. So 12 minus 2 gives me 10. So that means there's 10 triangles that I could get out of a 12-sided shape. What I do with that 10, I do 10 times 180 because the internal sum of one triangle is 180. So if I times it by 180, that will give me the sum of a 12-sided shape. So 10 times 180 gives me 1,800 degrees. So if I had a 12-sided shape called a dodecagon, fun fact, if I count the individual angles and add them all up, it should equal 1,800 degrees. And that's essentially it. That's our pattern rule. So if I give you an easier shape like a pentagon, so let's do our formula for a pentagon. So a pentagon has 5 sides. I minus 2, and that gives me the number of triangles, which is 3. So I get 3 triangles. I do 3 times 180 gives me 540 degrees. Oops. 540 degrees. So if I have a pentagon, if it is a perfect pentagon, as in all the sides are the exact same length, that means if I did 540 divided by the number of angles, which is 1, 2, 3, 4, 5. So if I have 5 angles, if I do 540 divided by 5, each angle is 108 degrees. Because if every side of this pentagon is the same length, that means it's a perfect polygon. That means if I take my final sum, my total sum of this shape right here, and I divide it by the number of angles in that shape, which if it's a perfect polygon, the number of angles in that shape will be the same number of sides. So if I have a hexagon, if it's a perfect hexagon, that means it has 6 angles in it, like it has 6 sides. So I take that 540, I divide it by 5 for the number of angles, and that gives me 108 degrees for each angle. Let's try that again with a couple other shapes. So usually when you're trying to find out the individual angles, it's that simple formula of the number of sides. So if I just gave you, let's do an example of a question you'll see. So let's do a hexagon. If I just give you a perfect hexagon, imagine that's a perfect drawing, and I tell you, find out what the individual angle is of each corner. How do I do that? Well, I take 6 for the number of sides, I minus 2. This gives me the number of triangles, which gives me 4. So I have 4 triangles. I take 4 and I multiply it by 180. 4 times 180 gives me 720 degrees. So the total internal sum of the angles of a hexagon is equal to 720 degrees. I take that 720 and I divide it by the number of angles I have. I have 1, 2, 3, 4, 5, 6 angles. 720 divided by 6 gives me 120. So each angle is 120 degrees. So that just shows you that all the angles are the same. And that is the rule. So what you're going to be doing today is you are going to be using the rule for the sum of all the angles in the polygon, but you're going to be given perfect polygons, as in like hexagons, octagons, pentagons, all that. So common shapes that have the same number of sides all the way around and the same length of all the sides, so they're not wacky shapes. What you're doing is you're using that formula to figure out how many triangles that shape would make up. With that number, you find out what the internal angle is for all those shapes. So you have to find out the total number, as in for the hexagon, we found out it was 720. and we divide it by the number of angles on the inside, which is the same as the number of sides. That will give me the angle of each individual corner. So I'm going to do one more example with you guys, and then you guys will be good to go. So it's pretty simple because once you figure out the formula, all you're really doing is just plugging in numbers. So if I have an octagon, which is, imagine is perfect, of course, octagon, so it has 8 sides. I do 8 minus 2 to figure out the number of triangles, so that gives me 6 triangles. I take my 6 triangles and I multiply it by 180 because, I multiply by 180 because each triangle adds up to 180 degrees. I take that 6 times 180, equals 1080 degrees. So the total sum of internal angles of this shape is 1080 degrees. I take that 1080 and I divide it by the number of angles. The number of angles is the same as the number of sides. So I have 8 sides to an octagon. I have 1, 2, 3, 4, 5, 6, 7, 8 angles. I take that and I divide it by 8, which gives me 135. So each angle is 135 degrees. 8 angles, 135 degrees each, means the total sum of that octagon is 1080 degrees. And that's it. So that's what you're going to be working on today. So make sure you're using the number of angles, because I saw a lot of people when they were submitting the work, they just did the number of triangles. That was my fault. I should have explained it better. Is you were supposed to figure out what the total internal sum of that shape would be. So for example, if you found out that shape gave you 5 triangles, you needed to actually do 180 times 5 to figure out the total internal sum. But that's okay, that was totally my fault. But that's what we're going to be practicing today. So you're just going to be using regular polygons or perfect polygons, ones that have ideal sides, because it would be too difficult to figure out ones that have varying angles because it doesn't divide up equally. But that's it for today. I will see you guys Monday. As always, if you have any questions, be sure to email me, and be sure to enjoy some of the weather outside. I hear Saturday is supposed to be really nice. I'm looking forward to actually doing some work outside. So here's hoping that the nice weather will continue. Otherwise, have a good weekend, guys, and I'll see you on Monday.